We're at the Czech Technical University in their hydraulics laboratory. We've got Scott Shipley and Riley Adams here from S2O, Mark Hunt, who's kind of a local representative from the Woodfin, Asheville area, and boat designer extraordinaire and freestyle paddler Shane Benedict, who can't seem to put down a shaper even when he's on vacation in the Czech Republic. And we are looking at the future Woodfin wave, which is right below me on this model, scaled at a 1 to 30 scale. Just to give you an example, these models are not linear scaled. So the rock and structure is 1 to 30. The flow is 1 to 1/5000. And time is scaled actually about 1 to 4. And so you'll see differences in how fast things happen out here. Time and velocity are obviously related as well. And then if you look upstream, you can see how we've calibrated this model to the French Broad River using computer models. And so that inflow coming out of that pool is kind of carefully calibrated to replicate what the water upstream of the future Woodfin wave, kind of where that craggy bridge is, will look like as it comes downstream. You can see the pylons of the craggy bridge there in the flow area. So we have a computer model of a long reach of the river that was provided to us by FEMA. And then on top of that, we've resurveyed recently a bunch of cross sections in this area. And then on top of that, we went out with a laser scanner and scanned either laser scanner or just a detailed survey and picked up all these places. And so I'll kind of zoom in. This is upstream of the Woodfin wave. You can see some of these features, which are undulations in the bedrock. And so it's actually quite an accurate survey. On this side of the river, we have the proposed drop structure. And so this is a surf wave. We've taken this very wide French Broad River and focused it into the center of the drop structure. The river is divided into two channels. We've also created on the far side this fish passage and safe boater channel with the idea in mind that a lot of the tubers and things like that may or may not want to brave the rapids. They certainly could. We're not creating something dangerous, but at the same time, something that's not intimidating, not hard to get down, and also easier for fish to get down. What you've got, this, like Scott said, this is kind of the low water, or the more focused channel for the freestyle feature. And the main thing we're doing, it's just so critical to get this elevation right. And these guys nailed it with that outflow to start creating the wave. And what we've been doing is slightly tweaking the angles of this opening and playing around with subtle changes in this, what we're kind of calling the speed block, and sort of moving things around to adjust the hole. So we're looking at a pretty big feature with a nice solid pile here, but like I said, curling out shoulders. And then the shoulders do have a little bucket to them with a side rib, that we were always looking for blunts and that kind of thing. Here's a funny scale thing for you. That's a 9-foot kayak.
It's been super useful using the physical model because we can see a lot of minor things that we can't necessarily see in 1D or 2D modeling, and they're much more they're not quite as exact as seeing it in real life like this. So a couple of the things we've been able to do is sort of calibrate our tailwater elevations using some local gauge data collected by Mark with our 2D modeling and 1D modeling. And then we've been able to see what that effect has had. So our water surfaces, we've been kind of adjusting the slope of these overflow plates, especially to get them down a little bit lower so that at high flows, we're creating more of a safe wave off the end of this and not a dangerous condition. We've also looked at the effect of removing these railroad piers from the river, which has lowered the tailwater in the middle of the river, lowered that water surface elevation, and all these things have an effect on that wave shape, what it looks like.
I'm extremely happy with the modeling that we've done. And one of the things that you hope for every time you do a physical model is that you'll turn it on and have to do nothing, right? You were right, the design was perfect and nothing to worry about. And one of the things we've done with this model is learn and learn and learn and learn. And so this has been a really worthwhile thing. And in talking to the representatives from Woodfin, the sort of interesting thing was him saying, look, we see the value in the model now. Like, this is great. We see it getting better. We see it getting better. We see it getting better. I don't think anybody would have been super unhappy with the product, But now we know we're getting that kind of world-class feature that we want to get.